Digging Deep, the Geology of Geothermal Energy. Title: Digging Deep, the Geology of Geothermal Energy. Introduction, approximately 100 words. Geothermal energy, a renewable source that taps into the Earth's natural heat, has gained prominence as an environmentally friendly alternative to fossil fuels. This article delves into the geology behind geothermal energy, exploring the processes and formations that make it possible. By understanding the science behind geothermal energy, we can appreciate its potential and explore its vast capabilities in a sustainable energy future. 1. Earth's internal heat engine, approximately 200 words. The cornerstone of geothermal energy lies in the Earth's internal heat engine. The Earth's core, composed mostly of iron and nickel, generates a tremendous amount of heat through geothermal gradients. The core's heat radiates outward, gradually warming the surrounding layers of the mantle and crust. This heat transfer provides the foundation for harnessing geothermal energy. 2. Plate tectonics and geothermal systems, approximately 300 words. The movement of tectonic plates is a crucial element in the existence of geothermal systems. These plates constantly collide, pull apart, or slide past one another. Such tectonic activity gives rise to various geological features like volcanic activity, hot springs, and geysers, which are indicative of potential geothermal reservoirs. Volcanic areas, especially along subduction zones and mid-oceanic ridges, exhibit abundant geothermal potential. In these areas, magma chambers heat the surrounding rocks, creating a geothermal reservoir. As water percolates down into the crust, it encounters these high-temperature regions, producing steam that can be harnessed for energy generation. 3. Reservoir formation and fluid flow, approximately 400 words. A geothermal reservoir is a subsurface rock formation containing significant amounts of heat and water. To create such a reservoir, several elements must come together. Porous and permeable rocks, CHs fractured volcanic formations or sedimentary basins, allow for the circulation of fluids. Water is the primary fluid in most geothermal systems, serving as the carrier of thermal energy. As water enters and interacts with the hot rocks, it absorbs heat, transforming into steam or superheat. Water. This fluid then rises to the surface through interconnected fractures, known as fault zones or veins, and manifests as geothermal manifestations, such as hot springs or geysers. 4. Geothermal power generation, approximately 300 words. Harnessing geothermal energy requires capturing the natural heat and converting it into usable electricity. The most common method is through the use of geothermal power plants. There are three main types of geothermal power plants: dry steam, flash steam, and binary cycle. In a dry steam plant, high-pressure steam from underground reservoirs is directed towards a turbine, which drives a generator to produce electricity. Flash steam plants, on the other hand, utilize high pressure hot water from underground reservoirs. As the name implies, the water flashes into steam once it reaches the surface, driving a turbine. Binary cycle plants, the most common type, utilize a secondary fluid with a lower boiling point than water to generate steam and drive turbines. 5. Environmental benefits and considerations, approximately 200 words. Geothermal energy boasts several environmental benefits. It produces virtually no greenhouse gas emissions during operation, reducing the carbon footprint associated with traditional power generation. Methods. Furthermore, geothermal systems have a small land footprint compared to other renewable energy sources like wind or solar power. However, certain considerations must be taken into account. Geothermal power plants require careful management of the reservoir's heat and fluid levels to avoid depletion. Additionally, the drilling process during the exploration phase may cause minor seismic activity in some cases. Proper regulations and monitoring systems must be in place to ensure the sustainable and responsible development of geothermal resources. 6. Geothermal energy and heat pump systems, approximately 300 words. In addition to power generation, geothermal energy can also be harnessed for heating and cooling purposes through heat pump systems. These systems utilize the stable temperature of the Earth's subsurface to provide efficient heating and cooling for residential, commercial, and industrial buildings. Ground source heat pumps, also known as geothermal heat pumps, utilize the relatively constant temperature of the ground to warm or cool air. In the heating mode, a fluid circulating in underground absorbs heat from the ground and transfers it to the building. In the cooling mode, the process is reversed, with the heat pump removing heat from the building and transferring it to the ground. The use of geothermal heat pump systems offers several advantages. They are highly energy efficient, as they require less electricity to transfer heat compared to traditional heating and cooling systems. EMS. Geothermal heat pumps also have a longer lifespan and require less maintenance, making them a cost-effective and reliable option for temperature regulation. 7. Enhanced geothermal systems, approximately 350 words. Enhanced geothermal systems, EGS, are an exciting avenue of geothermal energy that aims to expand the reach of geothermal resources beyond naturally occurring reservoirs. EGS involve creating artificial subsurface reservoirs by stimulating existing rocks with hydraulic fracturing techniques. This allows areas with low permeability or insufficient natural geothermal reservoirs to unlock geothermal energy potential. EGS technology has the potential to expand geothermal energy production worldwide, as it can be implemented in various geological settings. However, challenges remain, such as the high costs of drilling and the need for careful management of induced seismic activity. Ongoing research and development are crucial to enhance the efficiency and safety of EGS projects. 8. Geothermal energy and direct use applications, approximately 200 words. Beyond electricity generation and heating/cooling purposes, geothermal energy has numerous direct use applications. Hot water from geothermal reservoirs can be utilized for various purposes, such as agricultural irrigation, industrial processes, and even recreational activities like hot springs or spas. The direct use of geothermal energy offers several advantages. It reduces reliance on traditional energy sources and provides a reliable and consistent source of heat. It is also often more cost-effective compared to using fossil fuels, especially in areas with abundant geothermal resources. However, direct use applications require careful consideration of the availability and sustainability of geothermal resources. Proper management is essential to prevent resource depletion and maintain the long-term viability of the geothermal system. 9. Geothermal energy and global potential, approximately 220 words. Geothermal energy has vast global potential, with numerous countries worldwide already harnessing this renewable resource. Iceland, for example, relies heavily on geothermal power for its electricity and heating needs, while the United States leads in geothermal electricity generation. Countries located along the Ring of Fire, where tectonic activity is high, have significant geothermal potential. These include countries such as New Zealand, Indonesia, the Philippines, and Mexico. However, geothermal energy can be harnessed in various geological settings beyond these regions. Advancements in technology, such as eggs, have the potential to increase geothermal energy production in areas with previously untapped resources. Continued research and investment in geothermal energy. Why will be crucial to fully utilize this clean and renewable energy source on a global scale? 10. Conclusion, approximately 100 words. The geology behind geothermal energy provides a solid foundation for its sustainable utilization. From power generation to heat pump systems and direct use applications, geothermal energy offers a